Hi, this is Mr. Ward, and I'm doing a video key for Geometry Exit Ticket 6.3. So here are the two things you need to prove. So 4A says that we are trying to prove RM and RO. So we're trying to prove RM and RO are congruent. Now we've been given KRM and PRO. So let's label the things we've been given as congruent. So we've been given this angle and this angle. And if you're working on this, trying to do it all in your head, it might get tricky. You may want to just draw this thing out and give yourself some room. We also have been given that KR is congruent to PR. Okay, now that has just established that RKP is an isosceles triangle. And that is going to give us a whole bunch of useful information to prove that RM and RO are congruent. So after the givens, we can say triangle RKP is isosceles by definition of an isosceles triangle. Okay, and that's because it has a pair of congruent sides. Okay, once we've established that, we can then invoke Theorem 20, which says that, actually it's Theorem 19, which says that the base angles of an isosceles triangle are congruent. So we can say angle K is congruent to angle P, because base angles of an isosceles triangle, okay, those are the angles opposite the pair of congruent sides are congruent. Okay, and that's Theorem 19. I believe it was Theorem 19. It's either Theorem 19 or 20. I'm pretty sure it's Theorem 19. At any rate, I'm going to label that information. So let's label that information. So we now have that these angles are congruent. With that information, so we're looking for RM and RO. With that information, we can actually prove that RKM is congruent to RPO, which would help us because then it'll get us to kappa kata ka. So we can say triangle RKM is congruent to triangle RPO by angle side angle, because for congruent angles, congruent side, congruent angle. So the included side and two angles, so angle side angle. Now we can say that RM is congruent to RO because RM and RO are corresponding parts of congruent triangles by kappa kata ka. Corresponding parts of congruent triangles are congruent. Okay, and the next one, the way it's laid out in the book, it doesn't do the diagram. So you're going to start running into ones where you're going to actually have to draw it out. But I think you could draw that out. So this says the angle bisector of a vertex angle. So this is the vertex angle that it's talking about. I chose to include the diagram for you here because you don't have a lot of experience with drawing it out, but you're going to start needing to. So this is the angle bisector. OK is the angle bisector, and it says that in the givens. Okay, of an isosceles triangle. So we've established this is an isosceles triangle, and that angle bisector is a median to the base. Okay, so they've arbitrarily picked letters for the vertices and this intersecting point. We're trying to prove that OK is a median to the base. To prove that, we need to prove that this and this, that JK and MK are congruent. So let's start off with the givens and let's label them. Okay, so in here, this has identified that this is an angle bisector. So let's label that and label that. Okay, we've also been given that it's an isosceles triangle, and the angle bisector is heading, okay, so towards the base. So we're trying to establish this is the base, of course. So these angles are congruent, okay? We can, if it's an isosceles triangle, we can also establish that this side and this side, those sides are congruent. And then we can establish that also these angles are congruent. Okay, those are all things that we get out of it being an isosceles triangle. So we can say angle J is congruent to angle M by definition of isosceles triangle. And we can say triangle because there's also isosceles trapezoids out there. Okay, and we can say that OJ is congruent to OM by definition of isosceles triangle. Now, you could make a case that those are givens, but I think it's important to explicitly state that. Now, so we've been given JO, we're identifying JOM as the vertex angle, which is why we're treating JM as the base. Okay, so now we have some information about this triangle and this triangle. We can actually establish that we can establish now just by angle side angle that OJK and OMK are congruent. We could use the reflexive property to also establish that OK is congruent to itself. I'm not sure we even need to do that at this point. There are clearly different paths, and you may have taken a different path on this one, but this is one that I think is pretty straightforward. So we can now say triangle OJK is congruent to triangle OMK by angle side angle. Okay, and now we can say that JK is congruent to MK by kappa kata ka. Corresponding parts of congruent triangles are congruent. And then finally, because we can say that, we can say that K is the midpoint of JM, okay, by definition of midpoint. And once we've established that that's the midpoint, we can finally say that OK is the median to the base, JM, by definition of a median, because a median is a line that goes from one vertex of a triangle to the opposite side and bisects the opposite side. Okay, so there you have it. I hope that was